And I'm live. That is pretty cool. Today is 29th of January 2026, Thursday. And with that, let's start solving some problems. Yep, stop this video here. And yeah, SoundCloud, Max Rector. Max Rector. Okay, and today is also contest, Division 2. Yes, this one, Division 2. After years of hard work, we are euphoria to invite you to participate in Codeforces contest round 1077 Division 1 and 2, which will be held at Thursday, today, 20:05 UTC, 8:05 for me, us here in India. For both divisions, you will be given 7 problems and 3 hours. I do not like these contests which last for 3 hours because people start to cheat later on. To solve them for at least one of the divisions, one of the problems will be divided into 2 subtasks. Okay, one of the problems would be into 2 subtasks, and the score distribution will be announced later. We sincerely hope have a good contest. Okay, and now more problems to review. Before moving there, in the last contest, this one, there was this problem, pizza delivery, which we were not able to solve. Yep, so let's do this now. We had to figure out a way, like, yes, in this we had a coordinated space. Yep. Yeah. This problem. Okay, so what we have here is we are at a point in the x-axis and we cannot go back in the x-axis, and then on the next positive x-axis point there are multiple points we have to go through all of them, go to all of them, and then on the next layer there are other points, and then on the next layer there are other points, and then other points, then other points, so on till there is a last point at the end at some point. And our task is to go through all of these points without missing a single one, and we cannot move backwards, and we have to move the least amount of steps that we can. And in one step we can either move one point in x direction or in y direction. Okay, so okay, let's take one example. I think we did take this one. Yep, at some point when we were doing this for the first time. Yep. So our starting points are 1 1 here, 1 2, that is our starting point, 1 2, and our end point is at 7 3 at some point later on. And the middle points, they are, the first one is or the first one is 2 4 2 and 4, right here, 2 4, and then 3 3 and 3 1. Oh, 3 3 and 3 1, and then for 4 we don't have any point, and for 5 in x we have 5 1 and 1 4 and 6, 1 4 and 5 6 at 6 here. And then yep, that is not the end at 6 and 7 7 3 is our final point, 7 3, this one right here. So we begin from this point and we have to get to this point from here. So from this to this. So, and in this layer there is only one point, so we must go this way. Then in the next layer, we can direct go to this point like this, and then down here, and then this, then this, and then this. That would be the answer. So one distance, two distance, because one, two, so three in total, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Answer is 19 somehow. X A Y and B X B Y X Y. Answer is 19 somehow. We begin from this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Answer is still not 19. These points are correct. 2, 4, 2, 4, cool, and then 3, 3, and 3, 1. This is at 1, and this 1 is at 3. Yes, so the distance between these two is 2. Or maybe you can think about these points, these things as lines. Yep, and yes. So from one line we have to go to the other line like this. We go here like this, then like this, then straight, and like this. We just have to connect these lines, it seems. And if these lines are like this, we start at some point, we will go to the point that is closer, or the one which is further away. Go here, you go there, you go here, and then here. Or if we were to start from here, then we will go this much distance up, and to end up at, well, let's see, we want to end up here at this point. So if we were to move forward, up first, then we will go this much distance up, and then from here we have to go here till here. So we will cover this much distance, and then from this point we will get to this point, for which we will go this much distance up, and from here we will go here. So this much distance, and from here to get to here we will move this much distance. But if we were to go down first, then we will go here. From here we will have to get up here, we will go there, and from here we have to go here. We will move this much distance, and from here we will have to go there, so this much distance, and from here to go there, this much distance. So in total, how much distance is green one and pink one? So here we see that these two cancel out each other, these two also cancel out each other, these two cancel out, this one and this one cancel out, right? This one does not cancel out anything. If we remove the ones which have been cancelled out, we just have these two distances remaining, right? So if this point was further down, let's say here, then this distance would be smaller. This would be just this much. Yep, this would be just this much. Where should we go at the end? Depends on where you want to go. Later on, maybe instead of looking from here to where we should go, maybe we can start from the endpoint and see which point would we prefer to come here from, which point is closer to this thing, to this point here, and whichever point is closer we would prefer to get here from that point. And we'll see then for the line before it, so we'll here like to end up at this point, and then for here this one is closer. So to start from this point, like we want our final distance to be like this, so we would like this point to end up here and go there and then go there, not go there, we want to end up here, so we want this to go down and then here and then here. I think that makes sense somehow. Hello, I thought you were going to build something like with Go first, then you jumped to web dev, and now you even left that. So, yep, jumping here and there. Right now, I'm doing like some other thing, and I was building Go because of some internship which I left, which I'm not doing right now. So no Go, and yeah, I want to do web dev. Next month, I'll start working on web dev. But before that, I have something to do, something else to do. N x comma y and end x and end y. Shit. Caps lock. Just one moment. For the USB keyboard, this should be control. This somehow changes every time on its own. C and N X Y E X E Y, capital Y. Okay, and then the other points. Vector, not int. We will use, we'll say points. P size would be n, and they would have pairs. And then for auto reference x comma y in pairs, c in x and y, and then sort p dot begin and p dot, and we have all of our points. Okay, and ls equals 0 for int l equals 0 and l r equals 0, r smaller than n, l equals r, while r smaller than n, and p r dot x dot first equals p l dot first. What is j is missing? Okay, while this is true, r plus plus. Okay, and int minimum y if if r is smaller than no int minimum y, minimum smallest value of y is the one at L, so P L dot second, and maximum y is P R minus 1 dot second. So for each value of x, here we have three separate values of x. First we started from 1 and 2. 1 and 2 is our starting coordinate. Then for x equals 2, we have just one value of y, which is 4, which is also the minimum and also the maximum. And then for 3, x equals 3, we have 1 and 3 y values. 1 is the minimum and 3 is the maximum. And then for 4, shit, I messed up. Nope, I did. I looked at x values instead of y. These are the x values and these are the y values. For x equals to 2, we do not have multiple values. For x equals 3, we have 1 and 3. Then for x equals 4, we don't have any value. Then for x equals 5, we have smallest as 1 and the largest as 6. 1 and 6. Okay, and we can also count our initial value here. For x1, we have minimum 2 and maximum also 2 y value. The answer has to be somewhere from this relation. So for the x part, no, one more thing for the final value. Finally, we want, when we are at x equals 7, we want to be at 3. So in x direction, we will go from 1 to 7. So total distance is 7 minus 1. Yeah, 7 minus 1, 6. Total distance in x direction is 6, but in y direction, here 0, here 0, here 2 and 5, plus 2 plus 5. We begin from here. We either go from this point to the minimum or the maximum, both are same, and therefore we add 2. Then when we are 4, from 4, either we go to 1 or either we go to 3 or we go to 1. 3 looks closer. Let's go to the one that is closer. So yep, let's go to the one that is closer to us. So we'll go to 3, and at the end we will end up at 1. Yes, and then we will end up at 1. So this distance from 4 to 3 is 1. So we do plus 1, and now we are at 1, the opposite end. And from 1, either we go to 1 or we go to 6. We will go to 1. 1 is closer, and distance for that is 0. And then we end up at 6. Okay, and now from 6, we either go to 3 or we go to 3. 3, we'll just go to 3. So plus 3, and yep, and this is 8 to 10. 10 plus 4, 19. Shit, that is the answer, 19. That seems to be correct. Okay. Int current y equals initially not equal to 0 but equal to y, no, equal to y. Response is not initially equal to 0. Response is equal to end x minus initial x, right? And then response plus equals maximum y minus minus minimum y, the inner distance, and rest plus equals minimum of absolute value of maximum y minus current y. Okay. If absolute value of maximum y minus current y is smaller than absolute value of minimum y minus current y, then we will go to the maximum y point. Then we'll go to the maximum y point and rest plus equals mx absolute value of mxy minus current y, and current y would become equal to minimum y. Else rest plus equals absolute difference of minimum y minus current y, and current y will become equal to maximum y, and that seems good enough. Or maybe not, we are getting wrong answer for all of them. This we did calculate and we are getting wrong answer here. We did 6 plus 2 plus 5 plus 2 plus 1 plus 3, which is 8 plus 2 10, 15 plus 4 19. This should be 19. Current y, minimum y, and maximum y is plus equals minimum y mx y minus mny. That part is correct. And then if mx y minus cy if if mx y minus cy I think we have we messed up. If we have a point here and then we have 2 points, let's say like this one is closer and this one is longer. According to our formula, we will go to this point, and from there we will end up at this point. And let's say the next 2 points are like this. So this one is closer, and to get here we will move this much distance, and that is not very good. Was in total this part, this part, this part, and this part, and this part. In total we are moving this part through this part 3 times and through this part 2 times, which does not seem good. Instead, if we were to go to this point first, we will go down, then from here we will go up to this, and then here. And yep, we will be skipping 2 of these. We will be saving 2 of these points, of these distances, which would be cool, which we are not saving now. But the problem right now is not that we are giving a higher answer, we are giving smaller answer. Minimum is this one and maximum is the other one. n auto res plus equals absolute current y also changes afterwards. Okay, we had this thing as 11 because 6 plus 2 plus 5, no, 6 plus 11, 5 is 11. 18 and then 18. After, okay, yes, makes sense because we are not going to the last point. Okay, so after this, we will, before sorting, push p dot push back a new point x and b. Wow. Now we should get a better answer. Still, we don't, because this thing is going till n. Shit. N plus one, or we could say p dot size. Okay, it keeps on running because we also have to make a change here. P dot size. Okay, wrong answer. We got right for this and this, but for these other two, we are giving the wrong answer. Here we are giving a smaller answer than the actual one for the third test case. Okay, if we make our coordinate system, we start at point 1 3 1 3. We start at this point, and then the next one is at 3 1 and 3 5. So 2 3 1 and at 3 5, and the next one is at 4 4 4 4, and we have to end up at 5 2 5 2 here. So we would begin from this point, we would go directly here. Makes sense. Then now we have a decision, either we go up or we go down. Which point to go to? We go up, then we will have to go down, and then we will have to move up. Then we will have to move up. The mistake that we are making is we are not, when we are going from this point either to this or this, we are not considering where we have to go on next. Yes, we are just greedily moving forward, which is not good. So instead we have to look at the final point that we have to go to, and from there we will look at like which point is closer and which point, from which point it would be preferable to end up here. So here only there is like just this single point, so we will come from there, that is 3 units of distance to come to get to this point, and here this one is closer, so we will go up 1, and here 4 5 in total, and this is at height 5 and this one is at height 1. We will move 4 down, 9, and from here we have to move 2 back, 11, and from here we have to move 2 up. Yep, 13, which is the correct answer. So let's go in reverse. Our current y, our res. Yep. If this is the way that we are moving, then what we have to do is push not this, but push x and y and then sort this whole thing in the opposite order, r begin and r, and sort in the opposite order. Current y would be end y, and okay, for r is smaller than p dot, size while p r dot first equals p l dot first r second. What is the problem with this? Why? While r is smaller than p dot size, okay, then yeah, we are moving backward up. So int mn or y1, one of the y's is pl dot second, and int y2, the second y is pr minus 1 dot second, and we have to look at which one is closer. So y2, if absolute value of y2 minus current y is smaller than absolute value of y1 minus current y, then we will move in that direction. Before that, res plus equals absolute value of y2 minus y1. And here, if this one is closer, we will move in that direction, absolute value y2 minus c y, yeah, y2 minus cy, and cy current y would become equal to the other one, which is the exact same thing, just in the opposite direction, and does not seem to be any better, helpful maybe. Right now we were getting correct answer for this one and this one, I think, and this one and this and this, and I think we will get, using this, the correct answer for this and this, plus equals absolute y2 minus cy, y1 minus cy, and current y would become y2. Let's, okay, we are not getting correct answer again for them now. Push back x and y and y, while r is smaller than p dot size. One of the y's is this, the other one is this, absolute, add this to the response. This should be working. We are here and then we move there and we add just this distance, which is 2, and from here we go to this point and we go down. We add both of these distances, this one and this one, up here and here. Okay, shit. This would not help. Like we have not done anything new. We have done the same thing but in the opposite direction, which does not help, and yeah, which would not help. And this is the problem that we are doing right now. So, so we can just go forward as we were, push back, and x and end y, and then sort p dot begin and p dot end in the ascending order, starting y is y, capital Y. Yep, no one would even know. P r dot first and p l dot first, while these two things are equal to each other and r is smaller than the size, we will increment r, like get y1 y2. Yep. How is our answer like smaller than the correct answer? We start from here, and yes, we already have added 1 2 3 4 to our answer, and then when we are here we look at which point is closer to us. There is only one point. We are at 3, and this point is, there are 2 points. There is one point at 5 and one point at 4. So we are at 3, we will go to 4, we will go to 1 or 5, does not matter, but it matters that this next point is closer to 5, so we should first go to 4 and then to 5. Yep, we should first go to 4 and then to 5. Let's say we do go to 4, that is a distance of 2. In horizontal we have already added the, in the vertical we have already added the horizontal distance, so that is a distance of 2. We add 2 to our distance, total distance, and we move from 1 to 5. We move from 1 to 5, that is total of 4 more vertical distance, and then from 5, height 5, we go to height 4. From 5 we go to 4, that is a distance of 1, so that's 1. And then from 4 we go to a height of 2, from 4 to 2, so we do plus 2, and 10 13, answer here is 13. Answer is 13, but we are getting 11 somehow. How much do you think a beginner can increase their rating in 6 months? Speak from your experience. Okay, my rating, I started in June last year and it went from like 0 to at maximum 1400. So that is how much you can improve. But I was not doing anything else. I was just doing competitive programming and nothing else. So yes, I also gave it quite a bit of time during my day, throughout the day. So it depends on how much time you are putting in. But in 6 months, if you put in quite a bit of time and effort, you can reach specialist. Right now, I am not a specialist. Like here, not a specialist. But today is a contest. Maybe that will change, and maybe this rating will go down. This, we will see. Like, to be serious about this now? There is just something about this problem which I cannot put my finger on, and it is like right in my face. It is somewhere. Coordinate geometry. This is coordinate geometry. So we have to reduce the problem. We are at some point. There are 2 points in the next line, and there are 2 more points in the next layer. So here the best course of action would be, let's only count the vertical distance. We go up from this point to this point. Then from this point to this point, we have to go down, which is this distance, and then this. Yes, this much. And then from this, we have to go to this, which is this distance, and we have to go down. So in total, here we spend this much distance. But if we were to start from the bottom, we will go from this point to this point, this much distance, and then we have to go up, which is this much distance. And from here we have to go to this point, which is this much distance, and then from here we have to go down, which is this much distance. And blue line here is shorter than the red line. Yep, blue line here is shorter than the red line, clearly, because these two lines cancel each other. So cool. And there we just have more of, do we have more of red line? If we were to move this point high above, let's say we were to move this point down below, then let's say if this point was here, then this blue line would extend till here, and this one would become shorter and would go till here, and that red line would be like this, and one more like this. It seems like there is no difference in whatever point we go to. And there is this and this come together to make this distance. Blue line actually seems longer now. Looks like long. Looks longer. And there is no quantitative way to measure this. Hello, 800 problems are haunting me in my dreams. Is it over for me? By the way, how are you doing? I am doing amazing. How are you doing? And just solve more problems and try out this one, secret one, halloumi cheese problem. Have you done the halloumi cheese problem? This one, halloumi cheese. This one is easy. You will be able to do this. I was not able to do this, but you will be able to do this. Halloumi cheese. And shit. Coordinate geometry. Okay, right now, like as you can see, I'm struggling with coordinate geometry. So what do we do when we struggle? CP handbook. We pray here. CP handbook. Graph algorithms. Nope. Advanced algorithms. Yes. Advanced topics. Number theory. No. Combinatorics. Probability game theory. Square. geometry, yes, that is what we want. Distance functions, points and lines, more specifically this is where we are struggling. Sweep line algorithms, segment tree revisited, square root algorithms, no. Let's read a little bit of geometry. Yeah, let's do this. In geometric problems, it is often challenging to find a way to approach the problem so that the solution to the problem can be conveniently implemented and the number of special cases is small. Yes, sounds familiar. As an example, consider a problem where we are given the vertices of a quadrilateral, a polygon that has four vertices, and our task is to calculate its area. And our task is to calculate its area. Okay, let's just think about it. If we have 4 points, we have a quadrilateral, we have to find out its area. We can divide the quadrilateral into two triangles, this, which we can just choose by, we can decide on triangles from the 4 points that we have. If we have 4 points A, B, C and D, we can just choose these two to be part of both the triangles, and for the first triangle we can have A, B and C, and the second triangle would be A, B and D. And if we have points of a triangle, we can find out its area. How do we find out area of a triangle if we have points? If we have points, let's see, if we have, now our problem is not this, we have reduced this to finding out area of a triangle given 3 points. I think we can use Heron's formula. I, there would be a direct way to calculate this area using the points. If we have points x1, x1, y1 and x2, y2 and x3, y3, there would be a direct way, but I guess I don't know it. So let's use Heron's formula where we need to have the sides. If the sides are A, B and C, this side is A, this side is B, this side is C, this is not C, this is C. If you have three sides, I think it is that there is a thing called S, A plus B plus C divided by 2. This is S, and the area is under root S. Okay, I don't know, I'm just speaking out of my ass how to calculate uh, Heron's formula. Class 9th, yes. Close enough, close enough. S into S minus A, S minus B, S minus C. But calculating S is not very good. Calculating ABC, for to calculate ABC, now we have reduced the problem even further. We have been given 2 points, we have to calculate the distance between them, which is just x2 minus x1 whole square plus y2 minus y1 whole square whole under root. That is one side. We have to do this for all of these sides, A, B and C. Yep, A, B and C, and then put them into Heron's formula. S minus A, S minus B, S minus C. And in this book, do they have some example points? Heron's formula, let's go. Okay, but I think Heron's formula would not be very efficient because we have to calculate this S. We have to calculate this S. And calculating this S is not very cool. We have to do apply this formula 4 times for each of the side. Did already. Let's go. Half base x height. Yes, half base into height. I guess it works for quadrilateral triangles. Calculate sides with distance formula from points. Yep, yep. Sides with this. But here we don't know height. Like, what would be the height? So here, using Heron's formula is better if we already have the heights. But is there a way through which we can skip this part of calculating these sides and just get the like area of a triangle given these points? And we don't have to apply Heron's formula and calculate this S, and to calculate this S we have to calculate the sides using this. And hello. Yeah, okay. Triangle using points, coordinates, yes. We can use this thing, this formula, step-by-step calculation. Leave, substitute into formula, plug these values in. Okay, that no shit. Half, and this is modulus. Okay, we can use this. And this is a side quest for a side quest. So, okay, we know how to calculate area of a triangle. And also, the nice thing is that if we have a triangle, then how do we prove that its sides sum up to 180? If this is theta 1, this is theta 2, and this is theta 3. If we want to prove that its sides sum up to 180, we can have a imaginary line here, which is thick, shit no, which is thick like this, and we are making this line so that smaller. This is parallel to this, and if this this line and this line are parallel, then this angle would also be theta 1, because if these two are parallel, then this angle equals to this angle. And same for this would be theta 2, and if we do theta 1 plus theta 2 plus theta 3, we get this big angle, this one, which is 180. Angle on a line is 180. Therefore, sum of angles of a triangle gave us 180, which is like cool, which is very cool. We can just prove it like this. Okay, for example, yes, one way to approach the problem is to divide the quadrilateral into two triangles by a straight line between two opposite vertices. Yes, after this, it suffices to sum the area of the triangles. The area of a triangle can be calculated, for example, using Heron's formula. Yes, divide the quadrilateral into triangles, find the area of the triangles, add them, where ABC are the lengths of the sides of the triangles sides, and S equals A plus B plus C divided by 2. This is a possible way to solve the problem, but there is one pitfall. How to divide the quadrilateral into triangles? Shit, what if we have something like this that makes sense? Shit. Shit, that makes so much sense. If the points are like this, what do we do? Here, shit. Here, the right triangle to make would be this one and this one. These two. But how do we know that? We can see that by looking at the picture, but we don't know that. For example, this one is a concave triangle because there is a cave. For example, in the following situation, the division line is outside the quadrilateral. Yes. However, another way to draw the triangle works. This one works. So it is clear for a human which of the lines is the correct choice, but the situation is difficult for a computer. However, it turns out that we can solve the problem using another method that is more convenient to a programmer, namely is a general there is a general formula. This one, x1 y1 minus x2 y1 plus x2 y3 minus x3 y2 and x3 y4 x4 y3 and x4 y1 and x1 y4 that calculates the area of a triangle whose vertices are these. This formula is easy to implement. There are no special cases, and we can even generalize this formula to all polygons. We can generalize this formula to all polygons. If we use this same formula for triangle, what will we get? For triangle, we don't have till 4, we have just till 3. So we can remove all this 4 stuff. Instead of 4 here, we can say 1 here and remove all this. Is this the same formula that we saw before? Area of triangle given coordinates. Here we have half and we have taken stuff common. If we were to take x1 common, x1 y2 minus y3 plus x2 y3 minus y1 plus x3 plus x3 y1 minus y2 2 3 3 1 1 2, and this gives us the formula. Guess this gives us the answer apparently, but here we are doing half, so this does not generalize. Why are we not doing half here? General area calculation, general polygon area calculator calculation. With coordinates. Shoelace formula, uh, surveyor's formula, something like this. Okay, like whatever. Okay, let's go back to the book. This calculates the area of the quadrilateral. Okay, now we are moving on to complex numbers, I guess. A complex number is a number of the form this. We have a normal real part and an imaginary part. Heron is redundant, good for some crazy shapes I see. Redundant. Yo, hello, Kakashi. Bro, I watched 4 episodes of JJK in my dream, okay, and I didn't even saw them IRL, yet I guess I just made them up, the whole story with some shots I saw. Yes, that does happen. That does happen. You are not reviewing CF problems. I was reviewing this one, but we were facing a lot of difficulty, and I just like want to read some theory for now. This one, that is our quadrilateral, and so no half, but you have to do a half when you compute for triangles. I hope it makes sense. Yes, but I also reduced the sides. Right. Uh, I mean, if we had to do half, maybe. Okay, they are just saying this is for a quadrilateral, but if you want to generalize, I thought maybe we can just reduce the sides here, reduce the number of points we are using, and it would work. But I guess there is also a factor which has to be multiplied, which depends on the number of sides. And if it is 3, then we multiply this by half, and if it is 4, the number of sides are 4, we multiply this thing by 1, and so on and so on, I guess. Okay. Are you randomly selecting the problems, or are you following the sheets? Like, okay, CP31, for CP31, uh, I currently am at 1600 rated problems, but they are difficult. They are difficult. Last time I did a stream on this, I spent 1 hour on this problem, 1 hour on this, but I was not able to solve any of them. So yeah, right now I'm like, I have to read some theory, work on my theory a little bit. Yep, geometry this. Yo, let's go. You will catch up, you will come up. Try this one. I just solved it, and it is not even that hard once you will see the solution. Okay, let's see. And Codeforces. Shit, okay. That is some cool geometry. Stop. Watch. Okay. This is an interactive problem, okay. The pink soldiers. The pink soldiers hide from you and hide from you n fixed points, okay. And these whose coordinates are not given to you. Also, it is known that no two points have the same coordinates and no three points are collinear. No 3 points are collinear. You can ask the friend one about three distinct indices I, j, k. Then he will draw a triangle with points these and respond with the following. If at least one of the hidden points lies inside the triangle, then the frontman gives you the index of one such point. Do note that if there are multiple such points, the frontman can arbitrarily select any one of them. Okay, otherwise he responds with 0. Our objective in this problem is to find a triangle not containing any other hidden points such as the blue one in the diagram. Okay, these are all the points, and blue one does not have any other points. No two points are collinear on the same line. Using at most 75 queries, you must find a triangle formed by three of the points not containing any other hidden point, and we have been given 3 points in the start. You can ask the about 3 distinct indices. Okay, we give them indices and he will give me 3 points, and there are in total 15,000 points. Okay, do note that the frontman may be adaptive while choosing the points given to you. In other words, the choice of the point can be determined by various factors, including but not limited to the orientation of points and previous queries. However, note that the sequence of points will never be altered. Hexar, yes, will be judged on exactly 35 input files, including the example input. Interaction. For interaction, each test contains multiple test cases. The first line contains the number of test cases t, and then we have n, the total number of points at maximum 15,000. Afterwards, you can output the following on a separate line to ask a query. Question mark, IJK, give me these 3 points. Yep. Then the interactor responds with one integer on a new line. If your query is invalid or the number of queries has exceeded 75, then the interactor will respond with -1. If there exists an index p such that the point this is inside the triangle, then any such index p is given, otherwise the interactor responds with 0. If you want to print an answer, you can output the following on a separate line. This is the answer. Okay, the triangle formed by this contains no hidden triangles. Then the following interaction happens. If the answer is invalid or the triangle contains another hidden point, the interactor responds with -1. If the answer is correct, and there are more test cases to solve, you are given the value of n for the next test case. Otherwise, it means that all the test cases are solved correctly and your program may terminate gracefully. Do note that printing the answer does not count towards the number of queries made. Six points. We choose 1, 2, and 3. Okay, it gave us 5. That point number 5 is in the middle. We are only dealing with indexes. We have at max we have at max 15,000 points and we cannot do more than 75 queries. Let's say in the worst case, we start the 3 points that we start with have all of the other points inside. Can we just move forward normally like this? No, we cannot do that. Nope. We do not have the points themselves. We just have this one is the problem, just in case. Each query, do not forget to output yes plus line idleness limit. Get this. And no two points are collinear, so that yes makes sense. Cool. No two points are collinear. No two points are collinear. Okay, so like something like this cannot happen. But if we begin with a triangle that has all the points, no 3 points are collinear. That must help in something, I guess. No 3 points are collinear. No 3 points are collinear. We start with a triangle. We get that there is one more point which is in between them. Okay, then we can have 3 choices we could go with. 3 different triangles. This, this, and this. Yes, and if you go with this, we will have some point and 3 different choices. For this one also, we will have three different choices. For this one also, three different choices. And what do we do with the fact that no 3 points are collinear? We do not have points like this, 3 points which are on the same line, which just means that if we were to choose these points, then mm, every pair of 3 points is a triangle. With, yeah, just this. I think that is the only thing what it means. Every choice of 3 points is a triangle. Okay. $75. We get 1 point. We choose it this side, and with this side. Let's say all of them give us 1 point. So we had 3 triangles in total, and all of them gave us 3 more points. And each of them will have their own 3 triangles. So 9 triangle in total, and we did 1 triangle this. Then we went with 3 different triangles, so 1 plus 3. Then we had 9 choices plus 9, then 27, and yeah, then we won't be able to make any choice. We'll run out of choice. We can make 75 choices, 75 interactions. 30 plus 10, 40. We have 35 choices left. And we cannot just hope that this works. If we have a triangle to this, if we just have points like this all over, next would be this, next would be this, and using 75 choices we won't be able to go through like enough things. 1500, 1500, and minimum 3. and every pair or whatever, first thought, and every pair or combination of 3 points is making a triangle. So for every x value there are not more than 1 point. For every y value there is not more than 1 point in that thing, and I think there cannot be more than a given number of points in a single triangle, maybe, but the triangle can be very very big. Yep, that triangle can be very very big. Yes, we are not even given how big the triangle can be. Yep, the triangle can be very big. Yep, and yeah, we will be able to accommodate 1500 points inside a triangle. No 3 points are collinear. Not containing any other point. Not containing any other point. Using at most 35 queries, we must find a triangle formed by 3 points, not containing any other point. And we cannot even know how many different points there are in a division, so that we would go to the one with the minimum number of points. Interaction ij k, then the guy gives us a new integer -1 or index p, otherwise 0. Ijk, if we have 7 points, these are 7, we go here, get another triangle, and we go here, one more triangle. If the answer is not valid, okay, but if he's given the same I, j, and k, we do not know if we will get different points or not. Hmm. Hmm. Me thinking. Me thinking. If we have a lot of points, every point, every 3 points make a triangle. Let's say they are in such a way that no, three of them are collinear. All the points would be either in or out or triangle. For every line of points, we will have a point that is closer to them and will not have any other points in the middle. For every pair, we will have something like this. Multiple even. Here, this triangle and this one, even this one works. This also works. And this also works. Multiple the closest point. But we might also have other points in the middle of both of them, all of them. Mhm. I really am not having any idea. Don't focus much on collinear. It is just for making 3 points make a triangle. Now I'm literally not getting any idea, any intuition, nothing. Geometry, yes. 3 points, 3 points, reduce them, find a smaller triangle, find a triangle that does not have any other points in the middle. and the only now information that we are getting is indexes of those points, and whether there are other points in middle, in between of them. We have to fix something and move something else. Either we fix a line or move the point, or we fix a point and move the other 2 points. Till, and when do we stop doing this? Nope, no idea. Shit. Policy-based data structure. Yes, I know a bit. Uh, it all depends on the choices like you made earlier. 3 different choices. Each time you won't believe the solution, bro. Okay. Policy-based data structures are cool. They give you sets which are ordered. Like, yes, which is pretty cool. Thinking to ask the query like you ask ABC and interactor gives X. The next choice can be X ABC. Yes, three choices like this. Now there are 15,000 points and only 75 queries. Yes. $1,500 points and 75 queries. Mm, yes. A, B, C, first choice. Then A, X, C, X, B, C, X, A, X, A, B. 3 choices, then this will lead to 3 more choices, 3 more choices, 3 more choices, 9 choices, and then 27 choices. But that is not helping us. 3, 9, 1, and then 20, 27, 40 choices. If you want to go through the full fourth layer, layer 1, layer 2, layer 3, layer 4, 40 choices made to go through the fourth layer, then 81 more choices. And what are the number of points that we have gone through? After each choice, we get a new point. New point. This choice gave us 1 point, which was x. These choices gave us three new points: x dash, x double dash, x dash dash dash. Then we made 9 other choices and got 9 other points. We have gone through. We have got 40 new points. Mm, 40 new points. And with each choice made, we are reducing our search space by some point, but we can always arrange those points to always have like a lot of points in the middle. Always have points in the middle. No matter how small we go, we would have to go through all the points. Randomize, like we don't go through all three choices. Once we made a choice to a particular part, then other two. Shit, okay, okay. Mm, I think then also this would not work. Like this was the first instinct. Like here, let's say we get one choice, right? And let's say we select this triangle, then we got another another point, and let's say this time we chose this triangle, and then we got another point, and let's say we got this triangle. It could happen that every time we are choosing a smaller triangle, we are only choosing the one which has the maximum number of points in the middle. Or we can hope that out of the 75 choices that we make, we didn't always make the bad one, and we can hope that it works. Let's say let's make this work on hope. One plate, remove this, sync with stdio and null pointer tie, solve cn and n, cn n. Yep. Okay, a comma b comma c equals 1, right? B equals 2 and b equals 3. Okay, and while true, C out A, B, C, and a question mark or printf, with a question mark and a new line, B, C, Cn, flush standard out, and maybe we don't have to use this, we can use it. Let's see afterwards, we'll see. Now x, now we have to make a choice. Let's say int I equals 0, right? I equals I plus 1, remainder 3, and instead of ABC we should instead be saying int array 3 equals 1, 2, 3. And we can even yes, we can do this. A B C equals array. Let's go and make this a reference so that we can also use them as ABC and also use them through the array. After getting this, we will update array I to be equal to f. Wait, before that, if x, and you can do b is break if x is 0, and if x is 0, then yeah, here we'll just say auto reference a b c equals uh, and if this actually is the answer, then it will be actually pretty cool. Printf a plus standard out, compile two test cases. First test case has 6 different things, 1 2 and 3. Okay, 1 2 and 3. Let's say this is 1, this is 2, this is 3, this is 4 5 and 6. So 1 2 and 3, let's say 4 5 5 1 5 and 3, 1 5 and 3. There is only one between them, which is 4. Now 1 5 4, 1 5 4, nothing in between them, 0, bingo, 1 5 4. And we have to now output 4 for the next test case. Let's say 0 and finish. Okay, I think this is called randomized algorithm. Let's see if this works. Then we will call this randomized algorithm from now on. No, like we do go through all 3 choices. Once we made a choice to a particular part, then the other part are gone. Yep, it works for flush. Endline works for flush. Wait, but endline in this case it would, right? I mean, but this is also fine. If I were to use endline, I would have to remove this, right? Because endline also has a new line character. Let's use both of the things, and you are saying that I should use endline, and you are not complaining on the algorithm itself, which means the algorithm is correct. Which means shit, this is crazy. If this works, this is crazy. E empty triangle. Is this division 3? It is. Running on test paper. Okay, this actually is somehow correct, I guess. Okay, maybe not. Time limit exceeded. Why? This thing never exited. We never got x equals 0. So randomized. Is this is a randomized algorithm. This is like a random choice, right? Always making a different thing change. This is kind of random. Okay, let's how to get a random number. Random number in CPP. Yes, shit. We need a seed, and then we have to initialize this empty, which is twister engine, twister, inform int distribution, dist, this distribution, and then this distribution takes in this engine and gives us a number. Mersenne twister engine, which takes in a seed. Seed is a random number. For that random number, we do chrono system clock now dot time since epoch dot count. Okay, let's do auto feed equals chrono clock now. Oh, or chrono system clock. Shit, yes, there are three clocks: system clock and high precision clock and one other normal clock, wall clock. The chrono. There are three clocks: steady clock, system clock, and high resolution clock. System clock, let's say steady clock, does not matter. Steady clock now gives us time, time, time since epoch. Where is time since epoch? Dot. Time since epoch dot. Now, what is the type of this thing? This is seed, okay. And the empty 199. Let's see time. It is in the random library. Guess. Okay, we do have to include this. Huh. Empty, and now the distribution, normal distribution, inform integer distribution, int distribution. Now type int this from 0 to 2, and we will say here int I equals this empty. That is a lot of work. Let's submit this now. We'll see. For endline, I meant you can write. Yes, but that looks ugly. Screen stuck. Shit. Okay. My bad. Okay, cool. Now it is working. My bad. Wait, I can just do random. There is a function like that. Okay, shit. Run function C++. Legacy using ran works fine in S and seeding random number equals. What does this do? Random library. There is also a random library in which we do all of this. Generate a random. This just generates a random number. And seed. We can skip all of this and we can say this equals random remainder 3, which what time limit exceeded on base test 17. Okay, okay, this is actually crazy. Screen is now okay. 45 minutes, but this is a different kind of problem because the case that uh, I was saying that we might always make the bad choice, the probability of that is very low after making 75 choices. Like among all of the points that are in there, mm, only few are going to give us a bad choice. Yeah, probability after 75 points would be very less. There is a fraction of points 1 divided by some x number, x which is greater than 1, and after making 75 choices, this probability is very low that we end up at a point which has stuff inside. And also we are randomizing, we are changing. Shit, this is cool, this is cool. And there must be in this book also random algorithms. Range, bit manipulation, probability, no. Random variables, which is in probability. Randomized algorithms, yes. Sometimes we can use randomness for solving a problem even if the problem is not related to probabilities. A randomized algorithm is an algorithm that is based on randomness. A Monte Carlo problem is a randomized algorithm that may sometimes give a wrong answer. For such an algorithm to be useful, the probability of a wrong answer should be small. Okay, so we cannot guarantee that our solution will always give the right answer, but depending on the probability, and the probability of getting a wrong answer is very low. So probably we will get the right answer. Okay, from 32,000. Okay. Yes, this is cool. I did watch a video by Ericto on random algorithms, but I never paid any attention. I thought maybe this thing is not for like normal people. I don't see. There is a video by Ericto. Random programming. Yep, this one. And there are multiple videos by him. Algo lectures. So there is only one. No, there are two. Random algorithms one and part two. Part one, part two. This is cool. This was a cool problem. This was a cool problem. When choices are high and queries are very less, don't fix it. Randomize it. Yes. It was nice. Something new problem. Yes. This follows a totally different model. And let's do the experiment. See out and line. And okay, I'm going to make a few propositions. One is this will work, what I've written here, and also this will work. But other proposition is on proposition, yes, proposition is this will also work, and also third is this will also work. So let's start with this. And yes, we are going to use Codeforces, the resources for checking our hypothesis. Yes, okay, it is working. I thought maybe not. And the second one, see out, new line, accepted, cool. This one will also work. Like this one has a higher probability of working than the other one. And we do know that this one will, like, of course, work. Cool. And this will all, of course, work. But if we were to add those lines, those system steady, should, what are the boilerplate lines? These two: input, output, stream sync with stdio, false, and cin dot tie, cin dot tie with null pointer. We were to to add these lines, then yep, input, output, stream sync with stdio, false, and cin dot tie. Now this will fail. Now, yep, now this will fail. Now this will fail probably, because the standard input output buffer and the stream buffer, this one CNC out, they are not synced. So either we always have to use CNC out, or we always have to use printf and scanf. And also today is a contest, so it is going to be, yep, idle. This is sitting idle. Yep, this is just sitting idle. So let's change everything to scanf and printf. And scanf percent d into x or address of x, and loading, idleness. But what we can do is we can use printf for output, and yes, we can use printf for output, and for input we can use cin, and that would work, and this would work. We can experiment now so that we do not mess up during a contest. and laptop. Okay, that was accepted. Yes, because we are pressing the thing. Okay, and yep. So yes, the only novel thing that I would say we have done today is the random algorithm for this one, which is cool. Random algorithm and random algorithm for this, and just that we are trying to do the the third last or second last, third last. Yes, third last problem. This one, pizza delivery from this contest, but we were not able to do this. I'll just add it to review. Yep. Save and move on to some other problem. Maybe. No, for now, okay. I want to stop solving problems and focus more on theory because, yes, I need some more theory. Don't want to solve more problems. Amortized? Nope. Let's do one of these. Probability, no, game theory, string algorithms. Let's go through graphs. Yep, I have not done graphs. So, yes, from tomorrow, it is going to be graphs. And from tomorrow, it is going to be graphs. Maybe I will either read these on a stream and solve some problems on a stream, or I, yeah, some combination of problem solving and going through these. And probably I would like to go through all of these chapters in a single stretch. That would be cool. And for today, this would be it. And but before ending, I would like to go through the wordle for the day. And Thursday, 30 quizzes every Thursday. Today is Thursday. What is this? We do know which country this is. Venezuela. Shit. Brazil. Okay, Brazil. This is not Venezuela. Venezuela also looks very similar. Random address. Shit. Why are people looking for random address in Venezuela? Venezuela also looks kind of like this. Kind of. Brazil has a lot of neighbors. Venezuela, Peru, uh, Paraguay, Uruguay, Uruguay, Argentina, Bolivia, Colombia, and French Guiana, French Guiana, and two more countries, Guiana, and one more country, which is like right there on the top right, northeast of Brazil. Guiana, French Guiana, and Georgetown. Georgetown is the capital of that place. Shit. Shit. In the top right, in the northeast of Brazil, this country, this, I cannot remember its name. And yes, right now we are just doing random quiz. If you want to join, you can join from here. This is the link. Georgia, Gabon, Gibraltar, Greece, Greenland, Grenada. I don't remember. Suriname. Yes, Suriname. Suriname. If that is the pronunciation, I don't know. Yep. Capital Brasilia. Brasilia. Where is Brasilia? Port? Inside? Inside. Flag. This one is, I don't know. This one, Argentina, I think. Brazil is this. This is Colombia or Venezuela. Colombia, I think. Colombia, Bolivia, Argentina, Paraguay, Uruguay, Peru. Okay, one of the facts, which one of these facts is true about Brazil? Was not a part of USSR, observes daylight saving. I don't think so. Top 20, bottom 20 in population density, maybe top 20 in number of World Heritage sites, I think so. Because there is the person with the hands. I think that is Jesus. Brazil is the birthplace of the globally famous martial artist known as, no idea, martial art, Muay Thai, Kendo, Capoeira. From 1822 until 1889, Brazil was a monarchy ruled by two emperors who both bore the name. Two people had the same name, Pedro. Shit, okay. Yes, this thing is in Brazil. That is, I think, Jesus Christ, the Redeemer. And coat of arms. This one might be it. Publicia Federativa do Brasil. This might be it. And Spanish, Portuguese, English, German. People speak German in Portugal in Brazil. That is crazy. German is Heise, and Portuguese, no idea. Meu nome, that is Portuguese. GDP, I would, okay, that is better than India's GDP per capita. Best GDP, Guana, 32,000. That is quite good. Population 100 million, 200 million. Peso, Real. Cities, Brasilia, Rio. I think Rio de Janeiro would come up, or maybe Sao Paulo. I got that name, or maybe shit. No, Sao Paulo is at the top. Area 8 million square kilometers. That is a lot of area. And yep, for today, screen was stuck the whole time. Restart capture. Okay, the screen was stuck the whole time. My bad. And yep, for today, that will be the end of the stream. And thank you for being here. Bye.